Hi, today I'm talking about LeetCode problem 1015, smallest integer divisible by k. What this problem asks you to do is write a function that takes an integer k and returns the smallest n that is evenly divisible by k, where n is entirely composed of the digit 1. And if there's no such n, you're supposed to return a negative 1. So their example, your input k is 1, your output is 1, because 1 is evenly divisible by the input, and 1 is entirely composed of 1s. So another example they give is if your input is 3, I should say what you're supposed to output is not the n itself, but rather the length of n. So here the output was 1 because n is 1, and the length of 1 is 1. I hope that makes sense, So here, 3 is your input, and the smallest number n that's divisible by 3 is 111, which has a length of 3, so 3 should be your output. And they explain that here. The smallest n, 111, which is evenly divisible by your input k, has a length of 3. And so then if you have an input where there's no valid n, so there's no number of 1s in a row, no matter how many 1s in a row you have, that are evenly divisible by this input k, 2, then you should just output negative 1. There's no positive integer n divisible by 2, where n is entirely composed of 1s. So that's what the problem is asking of you. And the first thing I did to think about solving this is I asked myself this key question. When is there no 1111n divisible by k? Because if I know that there is some value, then I can just go ahead and search all of my 111s until I find one that is evenly divisible by k. And when I do find one, then I can just return my result, or return the length of my result. Return the length of that one string. So when is it the case that there is no 111? So the first thing that occurred to me is if k is even. So if you think about it, an even number plus an even number is always going to be equal to an even number. I mean, that's pretty straightforward. And any even number kind of rules out ever landing on a string of 1s. So like the reason why I'm talking about addition, or why I'm saying, it kind of rules it out, is we can say, if a number is going to be evenly divisible by k, then you should be able to say k plus some number of k's is going to equal our n, our string of 1s. But because this would be even plus even, e plus e, that would simplify to an e. The next k is going to be an even, e plus e, whatever. We would never be able to hit an odd number, which is required to get to n. So if k is even, then we know the answer is negative 1. Other conditions, I just kind of asked, well, what if the number ends in 1? There, yeah, it's pretty obvious we can get to a 1. What if the number ends in 3? Any number where the digits summed to 3 is evenly divisible by 3. So 111, the example they gave. So we know numbers ending in 3, we know 3 has a solution. 5 is interesting because it's an odd number that has no solution. Multiples of 5 either end in 5 or they end in 0. So 10, 15, 20, 25. So no multiple of 5 will ever hit 111. 7 and 9, I found they had multiples that were divisible for 5 just by kind of exploring like this. 6, I find that they have 111 sequences that are evenly divisible. And so then I just I suppose you could say, conjectured that all odd numbers other than 5 would have a 111 string. And I tested this, and it seems to be true. So I'd say I haven't proven that, but it seems to be true, and it works well enough to solve the problem. So at this point, I can basically just implement it by saying what I'm going to do is check to see, is there a solution? Is there a solution? Is there a solution? If yes, search for it. And if not, return -1. So it's pretty straightforward. And here's my implementation of that solution. So the function that LeetCode requires me to write, smallest rep unit, div by k, I guess is the name they have for it. I'm just making this check. Is it even? Or is it divisible by 5? If so, return -1. We know we can't solve this. And otherwise, what I'm going to do is search for the answer inside of this generator function. So I'm going to say for each O in the result of this generator function, if O is evenly divisible by k, then just return the length of the string of O. And the reason for converting it to a string is just so I can easily use the length function, because that's the format that they want the answer to be in. They don't want you to return the number itself, they want you to return the length of that number. And so the generator function is just going to give me 1 strings, like strings containing only the number 1. And how that works, it's going to start with an in. So I'm just going to start it off. I know that I don't need to consider any 1 strings that are smaller in length than the input value, because that wouldn't make any sense. You can't evenly divide a number that's smaller than yourself. So the first thing I'm going to do is, it's kind of complicated notation, I think, to get to a simple idea, but just convert it to a string so we can again get the length of it, and then put the number of ones, put one character for each length of my input string. So if my input string had a length of 2, I would get 2 ones. If it had a length of 3, I would get 3 ones, and so on. And then just convert those 3 ones, 4 ones, whatever it is, number of ones into an integer. So ones will have a value of 1, 1, 1, 1, 1, the same number of ones as the number of digits in n. And then while true, we're just going to yield my ones value. After we yield it, we're going to multiply ones by 10. So multiplying by 10 means that the last digit is going to be a 0, and then I'm going to add 1 to it, so the last digit will change from 0 to 1. And so this generator, whenever it's called, it's just going to yield the next ones. So if I invoke this with 1 as my argument, it'll yield 1 first, and then 11, and then 111, and then 1111, and so on. And so I can just loop through all of these. And recall that we know there will be an answer eventually, at least I've conjectured that, so I can just run this loop in perpetuity until I find the answer. And so to test it, what I did was I used their examples, 1, 2, and 3. And then I just put in some random numbers because I couldn't think of anything that's really specific to this problem. It seems to me that my solution will work generally, or kind of not at all. So I was just testing it with a few different examples. And I tested it with their maximum constraint and with their minimum constraint, and then just some numbers that I thought seemed kind of weird or interesting to me. So I wish I had a better methodology for testing it, but testing it worked and seemed to kind of prove out my conjecture that there would be a valid in for all of those cases. As you can see, it's not the most performant solution, but I think without figuring out a kind of mathematical insight that would let me produce one values more intelligently, I don't think there's a more efficient way to search this space. So I'd need to have some kind of mathematical insight, which I don't have. And I think like possibly I could get it by reading the discussion forum, obviously. But one thing I did want to show is that it sometimes requires you to search a large number of ones to find the value that eventually solves it. So I think that's why this program is relatively slow, because I'm searching, in this case, I'm searching 600 plus integers to see if they're evenly divisible. So there's got to be a better way, but I don't have that better way. Actually, while I'm speaking, it's occurring to me that rather than just, well, I guess that idea is not fully formed, but there's got to be a better way. I don't know it yet, but this is at least a, I think, fairly straightforward or efficient solution. So that'll do it for me. If you enjoyed this video, let me know by clicking the like button. Leave a comment to let me know you're watching. If you want to see me solve about one LeetCode problem a day, then go ahead and subscribe. Thanks for your time.